So class 10 students, just looking at the situation of lockdown. I'm starting class 10th topic, and today the first topic, that is force and turning effect of force, I'm going to start. So have a copy and pen with you, because if you are writing all the points in your handwriting along with me, then only the classes are going to benefit you. Otherwise, you can see number of videos and you can listen to number of teachers. That will never be your own knowledge. Let me start the first topic, that is turning effect of force. But before that, you understand the concepts and all the points related with the force. Force, you have started actually its introduction you have got in class 7th or 8th, I think. But feel it, that what is force. Let me have a object, and this object is at rest, and now I exert a force pushing it. What happened? The object which was at rest starts moving, right? Take another example. The object is at rest and I pull it towards me, and the object which was at rest starts moving. So state of object changes from rest to motion. So what is force? Force is push or pull which changes the state of the body. You have seen just now. But look at the definition. Here a part of the definition says which changes the state of the body, and another part says which tries to change the state of the body. If I ask you to push a wall, will you be able to make the wall move? No. That means what? You are exerting force, but state of the wall is not changing. So in that example, the force is not changing the state of the body, it is trying to change the state of the body. So push or pull which changes or tries to change state of the body is called force. Now, effect of force, a very popular question in ICSE board. Which type of effects we can relate with the force? See, force makes a body at rest to move, right? Then force makes a body moving, which is already moving, to come to rest. Now take an example. You are going through your scooter and then you apply brakes. First, the speed of scooter decreases and then finally it comes to at rest. So brake apply the force to make the body which is moving to come to rest. Now take an example that this object is moving with help of a force. And then I apply another force, and what happened? The direction of the motion changes. See it again. The object is moving in a straight line. I apply the force and direction of motion changes. So the third effect of force is that a body which is moving changes its direction under the influence of the force. And fourth effect is that take the same object again, this object, and apply the force. What happened? The shape and size of the object changes. Yes or no? So force makes a body which is at rest to move, makes a body which is moving to come to rest, and a body which is moving, force changes its directions. and force changes the shape and size of a body. So note down all the 4 effects of force. Completed? Let me move to the next point. Types of forces. You have seen that if I want to make this object to move, I have to touch it. So there are forces which when come in contact with the body then changes the motion or shape or size. So those forces are called contact forces. For example, friction, normal reaction force, tension, spring force. And if I leave the same object from a height, what happens? It falls down. Why? You all know, because earth pulls it down. But can you see the earth pulling it down? No. Earth is not touching this object to pull it down. So earth's force, which is actually not touching the body but it is pulling it down through its field, is called non-contact force. And example of non-contact forces are gravitational field, electric field, magnetic field. And example of contact forces are friction, tension, normal reaction force, and so on. So now we are going to start with the contact force, and the first contact force we are going to discuss is a frictional force. Now you all are already having idea of friction. What is friction? When there is, see the word relative, when there is relative motion between two surfaces. A force which opposes the relative motion. I'm not saying motion, I'm saying relative motion between the surfaces is called frictional force. So you know the idea, but now I'm going to make you this to see the concept, to feel the concept in a larger perspective. What is this? Have you seen the trees from the window of the train when the train is moving? Of course, so many of you must have seen. When the train is moving in forward direction, what happens to the trees? They appear to move in backward direction, just opposite to motion of your train. But we know that trees are not moving, they are at rest with respect to the earth. So this is called relative observation. That means you are moving along with your train, and if you observe another object, for example tree, you will feel, or you can say the trees will appear to move in backward direction relative to you, not relative to a person who is standing on the ground. That person will say trees are at rest. But for you, the trees are moving just opposite to the motion of your train. This is called relative motion. This is called relative perspective of looking at the state of the body, whether a body is in motion, whether a body is at rest, and what is the direction of motion of the body. So that relative term I am using here with the friction. And why I am using this with the friction? Let me have another example. This object is moving towards right with respect to the paper. So in which direction paper is exerting frictional force? Of course you will say towards left. Now I am saying, just listen to the language I am using. The object is moving with respect to the paper, relative to the paper, towards right. So the frictional force experiences by the object is just opposite to its relative motion. Its motion relative to paper is towards right. So frictional force on this object relative to its motion is towards left. And the same thing which I told you I have explained is with help of a diagram. The object is moving towards right, so the frictional force with respect to the paper is towards left. Relative to the paper, motion is right. Now how this concept changes the things when I put an object over another object. Now see, if I start moving, see, I am exerting force on the lower object, right? Lower object. But the upper object is also moving along with the lower object. Now you will say, what is so difficult in it? This is common experience. We see it every day. But just recall the Newton's second law. Newton's second law says that if an object experiences a force, then its state changes. I am exerting force on the lower object, so it's quite natural that lower object starts moving. But I'm not exerting force on upper object. Are you getting this fine point? I'm not exerting force on upper object, but state of the upper object is also changing. This implies that not only my force is acting on the system of these two objects, there is some other force which is acting on the system, which is making the upper object also to move. I am exerting force on lower object, so only lower object is supposed to move, but the upper object is also moving. This implies that upper object, which was all at the rest along with the lower object, that also starts moving. So that is not because of my force, because my force is on the lower object. Upper object is moving and changing its state because some other force is acting on the upper object, and that force is beta frictional force. Now here you have to understand it. Just look at the two objects carefully. When I exert force on the lower object starts moving in forward direction. Now can you tell me what is the relative motion of upper object with respect to the lower object? See it again. Can you feel that when the lower object is moving forward, the upper object with respect to lower object is moving in backward direction? Can you feel it? So the lower object is moving in forward direction with respect to upper, and upper object is moving in backward direction. Upper is moving in backward direction with respect to lower object. So both the objects are having relative motion with respect to each other. Lower in forward direction and upper in backward direction. If I make it like this, then the lower object is moving towards right. So upper object automatically is having a motion relative to lower object towards left. Now friction will be in between these two surfaces. The upper will experience friction because of the lower surface, and the lower surface will experience friction because of upper surface. Now in which direction both will experience force, frictional force? See, when lower surface moves towards right with respect to upper surface, then lower surface will experience frictional force towards left. Are you getting this point? While the upper surface is moving towards left with respect to lower. So this will experience a frictional force towards right. Now tell me if you are getting the point. The frictional force on upper surface will be towards right, while frictional force on lower surface will be towards left, because they are having their motion in such a manner. And that is why when I exert force on the lower object, the upper object also moves, because lower object is moving because of my force, but upper object automatically, as soon as the lower object moves, the upper object has a relative motion, and since this is moving with respect to the lower object towards left, so it will experience frictional force towards right. So it also starts moving, but this object is not moving because of my force. This object is moving because of frictional force. And the whole concept we can understand with help of a diagram. See? If the upper object is moving towards right, then upper object will have motion towards right relative to yellow. So it will experience frictional force towards left. But the lower object, which is moving towards left, will experience a force in forward direction, in right direction. And the case which we just studied, what was that case? I was exerting a force on lower object. I was exerting a force with help of my hand on lower object. So it tries to move towards right. When it starts sliding towards right, the object which is above it automatically has its motion with respect to the lower one towards left. So there is a relative motion between the two. The lower one is having relative motion towards right, and the upper one is having relative motion towards left. So when I exerted force on the lower, this has motion towards right, and as a result it will experience frictional force towards left. But the upper object, since its relative motion is towards left, so it will experience frictional force because of the lower surface in right direction. So lower block is moving because of my force, and frictional force is opposing this motion. But upper block is not moving because of my force. It is moving because of frictional force. See, it is in the direction of motion. So friction here is actually helping the upper block to move. So frictional force is always opposite to the relative motion of the surface. Are you getting this point? The same case but in different way I explained here. Here, see, I apply force on the upper block. As a result, upper block starts moving towards right. So it will experience friction towards left. Lower block, which is in the starting not moving, it will experience, it will have a relative motion with respect to the blue one towards left. अगर ये इधर जा रहा है तो येलो किधर जाता फील होगा, लेफ्ट. So the lower block will experience a frictional force because of the blue surface in right direction. फिर से समझो, ये थोड़ा कंफ्यूजिंग लग सकता है पर कंफ्यूजिंग है नहीं. ब्लू राइट में जा रहा है तो ब्लू की सरफेस पे फ्रिक्शन लेफ्ट में, लेकिन येलो ब्लू के रिस्पेक्ट में पीछे की ओर जाता दिखेगा, लेफ्ट की ओर. तो येलो पर फ्रिक्शनल फोर्स राइट की डायरेक्शन में. और अगर ये फ्रिक्शनल फोर्स सफिशिएंट होगा तो ये दोनों साथ में राइट में चलेंगे. तो फ्रिक्शनल फोर्स किस पर डिपेंड करता है? डायरेक्शन ऑफ फ्रिक्शनल फोर्स डिपेंड्स अपॉन द रिलेटिव मोशन, नॉट ओनली मोशन. Is it clear to everybody? So, see what we have discussed. We discussed effective force, effects of force. Then we discussed the types of forces, and then we discussed the first type of force, contact force, friction. Second point of the friction is that frictional force is calculated with help of the formula mu, a Greek alphabet mu into n. Mu is called coefficient of friction, and it actually represents the nature of the materials which are sliding over each other. And n is called normal reaction force. This friction depends upon the nature of materials and normal reaction force, but it does not depend upon the area of contact of the two surfaces, and it does not depend upon the speed with which the two surfaces are moving over each other. So this is all about the friction which you must know in class 10th. Now come to the next contact force, that is normal reaction force. Now this object is experiencing a pull towards vertically downward direction because of the gravity. We say that pull of gravity is weight of this object. All right. So weight of the object makes this body to push the table down. Again listen to me. Weight of this body makes this object to push the table down, to push the surface down. नीचे की ओर फोर्स लगा रहा है. When this object pushes the table down, according to third law of motion, table pushes this object in upward direction. Pushing the table down by this object because of its weight is action, and the force of table on the object in reaction is called reaction force, and because that reaction force is vertically upward, the reaction force is perpendicular to the surface. Reaction force is perpendicular to the surface. Perpendicular to the surface. Which surface? The surface which is exerting this reaction force. Table is exerting this reaction force, so this reaction force is at 90 degree from the table. So this is not only reaction force, this is a normal reaction force because this force is normal to the surface which is exerting this force. The same thing I explained with help of diagram. See, the object yellow is on the table. Gravity is pull which creates the weight of the object. Due to this weight, this object pushes the table down. So many times, children and sometimes in books also, this gravitational force is labeled as action. No, This is force of earth on the object. रिएक्शन इस फोर्स का नहीं होता है, रिएक्शन होता है जब ये ऑब्जेक्ट इस टेबल को नीचे धक्का देता है अपने वेट की वजह से। फोर्स एक वेक्टर क्वांटिटी है जिसमें मैग्नीट्यूड भी है और डायरेक्शन भी, और वेक्टर क्वांटिटी हमेशा एक एरो से रिप्रेजेंट होती है। एरो का टेल वहाँ होता है जहाँ वो वेक्टर क्वांटिटी अप्लाई हो रही है। ये टेबल पर अप्लाई हो रहा है फोर्स, तो देखो मैंने रेड एरो का टेल टेबल पर बनाया है, और क्योंकि इसकी डायरेक्शन डाउनवर्ड है तो एरो का हेड डाउनवर्ड है। ये है एक्शन, ये एक्शन नहीं है, ये अर्थ का फोर्स है, लेकिन इस ऑब्जेक्ट का टेबल पर एक्शन ये रेड डायरेक्शन, रेड एरो रिप्रेजेंट कर रहा है। और टेबल पर ऑब्जेक्ट का एक्शन है तो टेबल का रिएक्शन इस ऑब्जेक्ट पर होगा ऊपर की ओर। दैट इज रिप्रेजेंटेड विद दिस ब्लैक एरो, and where we are supposed to draw this black arrow which is representing reaction force. See, this object is rectangular shape, or you can say it's a cuboid. और जब हम इसे टेबल पे रखते हैं तो क्योंकि हमको ये रेक्टेंगुलर पार्ट दिखता है तो हम उस रेक्टेंगुलर पार्ट को ही यहाँ पर रिप्रेजेंट करते हैं। Symmetrical object has its center of gravity at the center of the object. तो जो रिएक्शन फोर्स है या जो फोर्स ऑफ ग्रेविटी है, रूल ये है, स्टैंडर्ड मेथड ये है कि उस फोर्स को आप सेंटर ऑफ ग्रेविटी पर दिखाएं। तो रिएक्शन फोर्स इस ऑब्जेक्ट को एक्सपीरियंस हुआ, मैंने उसकी टेल सेंटर ऑफ ग्रेविटी पे बनाई और एरो ऊपर की ओर। तो ये है एक्शन विद रेड एरो और ये है रिएक्शन विद द ब्लैक एरो, एंड यू कैन सी कि रिएक्शन फोर्स टेबल के साथ किस एंगल पर है, 90 डिग्री पर। तो इसीलिए इसको कहते हैं नॉर्मल रिएक्शन फोर्स, बिकॉज इट इज नॉर्मल टू द सरफेस विच इज अप्लाइंग दिस फोर्स। इसका मतलब क्या हुआ, बहुत गहरा मतलब है इसका। If you don't keep the surface horizontal as in this case, and if you make the surface to be at some angle theta with the horizontal, तो देखो नॉर्मल रिएक्शन फोर्स जो हॉरिजॉन्टल सरफेस का वर्टिकल था, अगर सरफेस थीटा एंगल पर इंक्लाइन हो गई तो नॉर्मल रिएक्शन फोर्स भी थीटा एंगल घूम जाएगा। सी दिस इज अ सरफेस, रेड सरफेस, एंड दिस इज एन ऑब्जेक्ट। अब नॉर्मल रिएक्शन फोर्स किधर है, रेड सरफेस के नॉर्मल वर्टिकली अप, लेकिन अगर मैं इस सरफेस को थीटा इंक्लाइन कर दूं तो जो नॉर्मल रिएक्शन फोर्स है जो कि अभी वर्टिकल है, देखो क्योंकि नॉर्मल रिएक्शन फोर्स को रेड सरफेस के परपेंडिकुलर होना चाहिए। जब मैंने सरफेस को थीटा एंगल घुमा दिया तो कैन यू सी दैट नॉर्मल रिएक्शन फोर्स ऑल्सो रोटेट्स बाय एन एंगल थीटा फ्रॉम द वर्टिकल पोजीशन। तो नॉर्मल रिएक्शन फोर्स हमेशा अप्लाई करने वाली सरफेस के नॉर्मल रहता है। अगर सरफेस घूम गई तो नॉर्मल रिएक्शन फोर्स भी घूम जाएगा, लेकिन उस सरफेस के परपेंडिकुलर हमेशा रहेगा जो सरफेस इसको लगा रही है। तो व्हेन surface is inclined at an angle theta, the normal reaction force just follows one rule, that it should be at 90 degree from the surface. तो देखो ये भी वर्टिकल पोजीशन से, यहाँ वाली वर्टिकल पोजीशन से घूम गया, लेकिन जिस सरफेस ने इसको लगाया उसके परपेंडिकुलर रह गया। दिस इज नॉर्मल रिएक्शन फोर्स, कॉन्सेप्ट ऑफ नॉर्मल रिएक्शन फोर्स। Now in the next class I will first explain you resolving a vector, because in the next topic, work power energy, we need it very, very much. And we will also discuss the concepts which are related with the force, very important force, resultant force क्या होता है, कैसे निकालते हैं उसको, क्योंकि जब हम टर्निंग इफेक्ट ऑफ फोर्स पढ़ेंगे तो हम रिजल्टेंट फोर्सेस का एप्लीकेशन न्यूमेरिकल्स में करेंगे. तो आज हम लोगों ने इफेक्ट ऑफ फोर्स पढ़ा, टाइप्स ऑफ फोर्स, और कांटेक्ट फोर्स में फ्रिक्शन और नॉर्मल रिएक्शन फोर्स को पढ़ा. आगे बात हम तभी कर पाएंगे जब हम एक हल्का सा कॉन्सेप्ट समझ लेंगे कि रिजॉल्विंग द फोर्स, रिजॉल्विंग अ वेक्टर क्वांटिटी क्या होता है, कंपोनेंट ऑफ अ वेक्टर क्वांटिटी क्या होते हैं. तो you note all the points and go through the points again till we meet in the next class with the concept of resolving a vector, right? तो next class में आगे बात करेंगे, और आगे बात करेंगे contact force tension के बारे में भी. Till then, all the best beta. I paused the topics so that you can copy them.